Imagine this. 66 million years ago, Earth was an entirely different world. In an era governed by the same ruthless laws of the jungle we know today, colossal creatures with astonishing abilities roamed vast continents without restraint. Herbivores shook the ground with their tons of weight, while predators were nothing short of lethal killing machines. This was the golden age of the dinosaurs, the era when non-avian dinosaurs ruled the planet with absolute dominance. In the tropics, endless forests of giant ferns and conifers stretched to the horizon. Warm coastal seas teemed with massive marine reptiles like ichthyosaurs and plesiosaurs, while above, pterosaurs glided on broad wings like living shadows. Dinosaurs were the masters of every ecosystem, from small, agile velociraptors to enormous, long-necked sauropods. Countless species had been perfected through millions of years of evolution. By sheer chance, these giants vanished. Had they survived, the rise of mammals, and therefore us, would have been nearly impossible. So how did these rulers meet their end? Everyone knows about the asteroid impact, but the details, duration, and consequences of this catastrophe still astonish scientists today. A rock roughly 10–15 kilometers wide, torn from the asteroid belt between Mars and Jupiter, was hurtling toward Earth at speeds exceeding 20 kilometers per second. The impact struck what is now Mexico's Yucatan Peninsula. The energy released was trillions of times greater than the Hiroshima bomb, equivalent to about 100 trillion tons of TNT. It didn't just create a crater, it triggered a planet-wide chain of disasters. The Chicxulub crater remains today as a buried scar 180 kilometers wide beneath the surface. In the instant of impact, billions of tons of rock vaporized and blasted into the atmosphere, igniting global firestorms. Massive tsunamis ravaged coastlines, and seismic waves circled the globe multiple times. But the true killer was the dust and sulfur aerosols that spread through the atmosphere, blocking sunlight for years and ushering in a nuclear winter like darkness. Scientific models show that global temperatures dropped an average of 15 to 20 degrees C, and this cold period lasted decades, or even centuries. Photosynthesis halted, plants died en masse, and the food chain collapsed from the bottom up. The near absence of sulfur in the crater rocks and the worldwide layer of iridium, a rare element abundant in asteroids, confirm this scenario beyond doubt. Did the dinosaurs vanish the moment of impact? No. Fossil records, especially from sites like the Hell Creek Formation, reveal a brief survival window afterward. Some smaller species, particularly scavenging theropods, may have clung to life for weeks, months, or even a few years in isolated pockets. But ecological collapse was inevitable. Starvation, freezing temperatures, and acid rain brought the giants down one by one. Consider Triceratops. These horned herbivores, with their bony frills and massive shields, roamed in herds and were perfectly defended against predators like T-Rex. But when plants died out after the impact, their multi-ton bodies became unsustainable. Herds weakened, young died first, and adults succumbed to hunger and cold, collapsing across the plains. Tyrannosaurus rex was the terrifying king. Its bone-crushing jaws and earth-shaking roar struck fear across vast distances. Yet even it became a desperate scavenger, fighting its own kind over rotting flesh. With the food chain in ruins, this apex predator finally starved. Ankylosaurus was a living tank. Impenetrable armor and a club-like tail made it invincible against attackers. But its heavy body demanded constant food. When vegetation vanished, the armored giant slowed to a halt, defenseless against starvation. The catastrophe struck not only land, but the oceans too. Giant marine reptiles like mosasaurs disappeared, yet microscopic organisms like plankton slowly rebuilt the food web. Who survived? Small size, flexible diet, and the ability to find shelter were key. Tiny mammals burrowed underground, crocodilians endured with minimal food, and most importantly, birds. Modern birds evolved from small, feathered theropods, relatives of Velociraptor. Their feathers provided insulation against the cold, and their light bodies and flight allowed access to resources others couldn't reach. Microraptor's 4 wings, Avosaurus's arboreal lifestyle, Archaeopteryx's transitional traits. These were the features that endured the apocalypse. Today, we find traces of T-Rex in a chicken's genome and see theropod ferocity in a cassowary's claws. The Deccan Traps volcanoes had already stressed ecosystems before the impact, but Chicxulub delivered the final blow. Roughly 75% of species vanished, and almost nothing over 25 kilograms survived. In the Paleogene, mammals filled the empty niches. Pachycetus became the ancestor of whales, Miacids led to cats, Hesperoxian to dogs. Giant ground sloths gave way to today's tree-dwelling species, and snakes evolved from titans like Titanoboa to modern forms. What if the asteroid had missed? Dinosaurs might have developed intelligence. Species like Troodon could have built civilizations. Mammals would have remained in the shadows. Pterosaurs would still rule the skies, and mosasaurs the seas. But evolution is full of surprises. Another disaster would likely have forced change anyway. In reality, Chicxulub created the biodiversity we know today. When you hear a bird sing, you're listening to a legacy millions of years old. The story of the dinosaurs is as much about extinction as it is about survival and transformation. If you enjoyed this narrative, stay tuned for more discoveries in the depths of paleontology.